Hi, this is Richard C. I'm a math tutor at Wyzant, and I'm answering a question submitted by a student. I'm going to be answering this question based on an example, and the example I'm using is just the absolute value function. So we have a function y equals absolute x minus 5, and you can see that a graph is drawn there on the right. So we're going to see which of these statements is or is not true. F is not continuous. Well, you can see that F actually is continuous. A poor man's way of telling whether a function is continuous is to see whether you can draw the function without the pencil leaving the page, and you certainly can here. So this is true. And formally, what we would say, it's true because the limit as x approaches 5 from the left of f of x here happens to equal the limit as x approaches 5 from the right of f of x. And both of these limits is 0. So as we get near, as we approach from the left, you can see you're getting closer and closer to 0. As you approach from the right, you see the function is getting closer and closer to 0. And the third requirement is that f of 5 be 0, which it is. And so this is continuous at 5. Does the limit exist in this? So it does exist. So this statement is false. Because if the left-hand limit and the right-hand limit agree, then the limit, the two-sided limit as x approaches 5 is 0. Because the left-hand limit is 0, the right-hand limit is 0, so the two-sided limit is 0. Oh, not continuous, excuse me. So it definitely is continuous. Excuse me, I didn't see that. It is continuous, and the two-sided limit does exist. And then this one, the limit as x approaches 5 of f of x minus f of 5 all over x minus 5. That's the definition of f prime of 5, or the first derivative at 5. And this certainly exists as well. So this is false. Oh, excuse me. I'm sorry. I'm very sorry. I'm messing this up. I get my double negatives messed up here. This is true. This does not exist. Why is that? Well, if you just look at it visually, the first derivative is the slope of the tangent line. You can see the slope. Let me change color here. You can see that the slope here is 1, and the slope here is -1. So anywhere you're on the curve, this is, you can't define this tangent line here. It could be flat with a slope of 0, or it could look more like this. In other words, there's an infinite number of tangent lines that can be drawn here at this point, and therefore the first derivative is undefined. And now this last one, I don't know exactly what they're getting at here, where limit where 5 is upper and 0 is lower dx. I'm not sure what that means, so I can't really help with that one. But the rest of these parts are fairly straightforward, fairly classic calculus. I'm not sure about this last one, so I apologize for that. Anyway, that's it for this problem. I hope this helps you. This sort of thing is covered usually early in calculus, where you're learning the definition of the first derivative, and then you'll be going from here, you'll be going into more things. But calculus really begins with a study of limits, and you can see why. These limits determine quite a lot about whether a function is continuous and differentiable or differentiable. Okay, so that's it. I hope this helped, and I'll see you next time. Bye-bye.